In Exercise 5 we have this model, and this model is made of surfaces tools. So here we have to apply material alloy steel. We have to define the thickness of the material 0.15 inches. Although when you create a surface body, the surface body doesn't have thickness, but for aesthetic analysis you have to define the thickness. Then we have to define the fixture, immovable, and that fixture we will apply to those edges on the holes and on this edge here. And then we're going to apply a force to this face, 100 newtons. So the first question is, what is the maximum displacement in the x direction in millimeters? In the second, we have to modify the force value from 100 newtons to 20 newtons without creating a new mesh. And then we have to calculate what is the maximum displacement in x direction. And the third question we have to answer, are our results valid or not? So let's open our model. So since we have force in newtons and we have to answer in millimeters, let's go to simulation, options, default options. Let's choose SI system. For the pressure stress, let's go with Newton per meter squared. Let's check the mesh. We have high quality mesh. And now let's click OK. Now let's create a new study. Let's call it X5. Let's click OK. So the first step is that we have to apply material to all surface bodies. So if we open this, we have 4 surface bodies. So you can just simply right click here and let's go with apply material to all bodies. We have alloy steel, apply and close. And now if we check here, we have alloy steel on all surface bodies. The next step is that we have to define the thickness of the all surface bodies, and the thickness will be 0.15 inches. So we can go manually to one by one body and change the thickness, or we can select one, hold Ctrl, and then select the rest of them. Let's go right click and edit definition. Now here we have a type and we're gonna go with thin. So here we're gonna go with inches. Let's go with 0.15 like this, and let's click OK. And now we have here, as we see on the all surface bodies, 0.15 inches. In the next step, let's define fixture. Right click, let's go with fixed geometry, and we're gonna go with immovable. So we're gonna choose this edge here, this edge here, this edge here, and those two edges here, this circular edge and this one here, like this. 1, 2, 3, 4. Okay, we have to select again this one, like this. Now we have 5 edges. Let's click OK. So this is our fixture. Now let's go to external loads. Let's apply force. Let's apply force on this face. Let's go with 100 newtons. We don't see it. Let's go to the other side, like this. And this is the direction that we want. And let's click OK. And now we can go to mesh, right click and mesh and run. And those are our results. So we want to check what is the maximum displacement in X direction. So let's go to displacement, double click. Let's right click here. Let's go to edit definition. And as we see, we have in meters. That's why we don't see any results here. So let's change this to millimeters, like this. And let's go with X displacement. Now let's go to chart options. And let's choose here show maximum annotation, like this. And now let's click OK. And now we can see that the maximum displacement is 0.003 millimeters. Now if we change our force, right click here, edit definition, let's go to 20 newtons. Let's click OK. Now let's run this study again without creating a new mesh. Just click run here. Let's double click on the displacement. And now we see that the maximum displacement is 0.001. Now we want to check if our results are valid. Let's double click on the stress. So here we have a yield strength and here we have a stress. Did our stress pass the yield strength? No. So we can conclude here that our results are valid. But we want to be sure, we can right click on the results and we can define factor of safety plot. Let's click OK. And you can see that we have a big factor of safety. So our results are valid.